Welcome everyone. My name is Lilien Nagy, and I would like to present my PhD thesis title, which is the evaluation of mechanical and antimicrobial characteristics of dental polymers. I would like to present my mission, which is to decrease the incidence of denture fracture and the denture stomatitis, and my vision to develop a denture-based material with both antimicrobial and good mechanical characteristics. I have two specific goals. The first is the evaluation of flexural strengths and antifungal characteristic of polymethyl metacrylate incorporated with silver nanoparticles. Nowadays, 19% of people wear removable dentures, and the most widespread material is the polymethyl metacrylate, it has some drawbacks, like the denture stomatitis, which is caused mostly by infection of Candida albicans, and the other problem is the denture of the fractures. So this is why we would like to evaluate the incorporation of different nanoparticles, and in my first project I have chosen the silver nanoparticle because it is known, it has, and it is proven, it has an antimicrobial effect. So our aim to assess the effect of silver nanoparticles addition to PMMA on the mechanical and antimicrobial characteristics. Our clinical question: how does incorporating silver nanoparticles affect the flexural strengths and antifungal characteristics of dental acrylic resins? Our population was the dental acrylic samples, and the intervention is the incorporated silver nanoparticles. The control group was the PMMA without any silver nanoparticles, and we have three outcomes: the flexural strengths, antifungal effect, and the biofilm inhibition. Our hypothesis: the flexural strengths and antifungal characteristics of dental acrylic resin with silver nanoparticles is superior to the dental acrylic resin without any silver nanoparticles. After the systematic search, I have found more than 13,000 articles, and after the selection, 24 eligible articles remained. Let's start with the outcomes, and I will present first the mechanical property, the flexural strengths. It shows how the material can resist for bending forces, and there is an ISO standard for that. It should be minimum 65 megapascal to use it for denture, as a denture-based material. In the eligible articles, 4 factors were mentioned which has an effect or modify the flexural strengths. These were the silver nanoparticle concentration, the silver nanoparticle size, the curing time, whether it was short or long polymerization, and the fourth was the immersion of the samples, whether it was immersed right before the measurement in water for 50 hours or not immersed. And we made multivariate analysis and we included all these factors. You can see here the results of the flexural strengths, and this graph shows how the flexural strength changes as the silver nanoparticle concentration increases. On the vertical axis you can see the flexural strength in megapascal, and on the horizontal axis you can see the silver nanoparticle concentration. And we can see the other modifying factors like the immersion and non-immersion of the samples in the columns, and on the horizontal rows you can see the different size ranges. And also the polymerization techniques are shown by different colors. And to sum up the results for the flexural strengths significantly decreases as the silver nanoparticle concentration increases. And the effect of the other factors like the immersion or non-immersion, polymerization technique, and the size does not show significant differences. But there were numerical differences, so it is worth to further investigate these factors. And in terms of the long polymerization technique, we need more data and studies. Let's move on the second outcome, which is the antifungal effect. The antifungal effect shows the number of the cells in the liquid around the samples, and it is caused by the dissolved silver ions. And on this graph you can see the cell count on the vertical axis in logarithmic scale, and on the horizontal axis you can see the silver nanoparticle concentration. And with the increasing silver nanoparticle concentration, the cell count was significantly decreased. Let's move on the last outcome, which is the biofilm inhibition. The biofilm formation shows the number of cells on the samples which are adhered to the surface of the samples, and in this case we have the samples, the test samples which were incorporated with silver nanoparticles, and there was the control group where the control group doesn't incorporated with silver nanoparticles, and on this graph you can see the ratio of the cell count of the test groups to the control group in a percentage. And on the horizontal axis you can see the silver nanoparticle concentration. And here we can see in case of silver nanoparticle incorporated samples, the number of cells are significantly decreases in the silver nanoparticle incorporated samples to the control group. What were our strengths? In case of flexural strengths, these studies used the same method for measurement, and samples were made according to ISO standards, and there were some limitations as well. In case of antifungal characteristics, the conditions were different and the number of studies was low. And you can see here our main conclusions. The mean flexural strength decreases as the silver nanoparticle concentration increases, and in case of antifungal effect, there is a reduction in cell count with the increasing silver nanoparticle concentration. And incorporating silver nanoparticle into PMMA significantly reduces the biofilm formation. We have some implication for the practice. We recommend the highest silver nanoparticle concentration that does not reduce the flexural strength below the ISO standard, which was 65 megapascal. In this way, we can achieve the highest antifungal properties. And the other implication is to incorporating silver nanoparticle into PMMA, the prevalence of denture stomatitis is reduced. We have some plan for the future as well. We would like to develop a standard measurement for the flexural strengths and antifungal characteristics as well, and we would like to perform these measurements with our working group, and in the future we would like to evaluate other nanoparticles and bacteria as well. Currently I'm working on the manuscript writing, and we have chosen the journal as well. It will be the Journal of Prosthodontics. Let's move on to the second topic, which is the evaluation of mechanical and antimicrobial characteristic of polymethyl metacrylate incorporated with another nanoparticle, with the titanium dioxide nanoparticle. Our clinical question: how does incorporating titanium dioxide nanoparticle affect the mechanical and antimicrobial characteristic of denture acrylic resin? The PICO is really similar, but we would like to evaluate other outcomes like impact strength and micro hardness. And our hypothesis, the mechanical and antifungal characteristics are superior in the test groups compared to the control group. Currently I'm working on the preliminary research, and if I'm finished I will finalize my Prospero registration. And to sum up, our planned submission date for the first project is October, and for the second project is January. Thank you for your attention, and I would like to close my presentation with a quote: "Success is a sum of small efforts repeated day in and day out."
Thank you very much for the nice presentation. Any question from the audience? Encourage you to question.
Congratulations for your nice presentation. My question is about your second topic. Why did you choose the titanium dioxide nanoparticle?
Thank you. I have chosen the titanium dioxide nanoparticles because it is also has antimicrobial effect and corrosion resistance effect, and also biocompatible, and the price of this nanoparticle is cheaper than the silver nanoparticle because the silver nanoparticle cost is 5 times expensive. Yeah, thank you.
Thank you.
More question?
Congrats on your progress, very interesting topic. I had a question about the safety of nanoparticles. Like, are they safe to be used in humans on these concentrations that you showed?
Thank you very much for the question. Silver has toxicity, but in that low concentration, it is not harmful for the human body, so they can wear these dentures. Unfortunately, I have checked this toxicity as well, but I didn't find enough eligible article to include it in the meta-analysis. But in other studies, I have read that it's in this concentration, it's safety.
Thank you.
Thank you.
Thank you very much for your very nice presentation. And I have only one question. Do these nanoparticles used in daily practice anywhere in the world, or not yet?
Thank you very much. As I know, it is not used in daily practice. I have found some articles in which the dentists or researchers made silver nanoparticle or other nanoparticle incorporated dentures, but we need more evidence-based recommendation to use it in daily practice.
Thank you.
Thank you.
You mentioned a lot of research implication of the first study that you plan to perform. Why did you choose the meta-analysis as a second topic?
Thank you. Because I have found just one meta-analysis in that topic, and to use it in daily practice, we need more data about these nanoparticles, and I would like to evaluate more outcomes, not just the flexural strengths, but the antifungal and antimicrobial effects. So we would like to include more outcomes, and we would like to get more information, and maybe in the future we will use it, so it will be more safety maybe, or we will have more information, and maybe we can use it for the clinical practice.
Congratulations for the nice topic. Like once we tried to add this nanoparticles to the silicone, maxillofacial silicones, we improve the tensile strength, but in turn we increase the surface roughness and hardness. So like, was there a mention of a disadvantage, a possible disadvantage of such an addition in the articles?
Could you please repeat?
Like, was there a mention in the articles so a possible disadvantage of such an addition? Like maybe the flexural strength is improved, but the roughness and hardness is like worsened. So was there a mention of such a disadvantage?
Some articles mentioned hardness, but in case of silver nanoparticles, I didn't have enough article, so I don't know the correct answer for the first project, and currently for the second project, I will hopefully I will evaluate the micro hardness, so maybe in the future I can give you a correct answer about that.